At Syntho, we provide a smart de-identification solution to successfully de-identify your entire database, which essentially means removing the most sensitive data from your database and replacing them with mock values. Let's start by dragging all the tables we want to de-identify into the de-identify section. As you can see, some columns are immediately marked as PII and highlighted in red, indicating their sensitivity. But how do we know which columns are sensitive? We first start by running a PII scanner. In the PII tab, you'll see the results from a previous scan we ran, showing the columns identified as PII. On the left, you'll see the column labeled as PII, and on the right, you'll see the PII scan results with a confidence score indicating how certain the scanner is about the labeling. To run a new PII scan, click on Scan at the top. You can choose between a shallow scan, which only considers metadata, and a deep scan, which also analyzes the data itself using AI models, specifically entity recognition models, to determine if columns contain PII. Once we confirm which columns contain PII, we can replace them with mock values. For example, if a column is marked as address, we can apply an address mocker to de-identify it. We follow the same process for other columns, such as first names. You can also preview the values and apply the appropriate mockers. This is how we can successfully de-identify the database. Additionally, you can perform these actions from another screen. In the Job Settings panel, you can review the columns labeled as PII and replace them with mock values. The identified PII columns are also listed in our documentation, which we always refer to, ensuring they contain all the relevant PII or PHI for you. You can also add any custom PII or PHI entities based on your preference using the PII tab. For instance, if we want to identify the passport column as PII, we can manually do so here and then replace it with mock data, or we can also exclude it in this case. Now the passport column has been added as PII and successfully replaced. For instance, let's apply a mocker to the Social Security number column. You can do this by adding the Social Security number mocker into the mock data settings to replace this column with mock values. We can do the same for driver's licenses and passport columns using advanced mockers to define the data structure ourselves. For example, a driver's license column might always start with S999 and end with 5 random digits. To create this structure, go to the mocker settings, select custom text, and define the structure accordingly, starting with S999 and ending with 5 random digits, which is done by inputting hashes. If you hover over the icon on the right, you can get more information on how to use this mocker. Then you can preview the values and adjust settings, such as introducing some missing values by changing the blank percentage. Once satisfied, select Confirm, and the column will be successfully de-identified. Moving on to the next column, the last name column, let's replace it with a last name mocker. If we preview the values, you'll notice they are in English by default. However, if you want to use different language values, you can easily switch. For example, to use Dutch locale values, simply select the Dutch option. You can also choose other locales, such as Japanese. This gives us a variety of options to replace the data in this column. For this demonstration, I'll stick with the English locale and replace the last name column with mock values. Additionally, we can apply more advanced logic, like rule-based synthetic data, for more precise data generation. Now that we have seen how we can de-identify our columns, let's say we want to de-identify columns by applying mockers while also ensuring consistency so that the mocked values can be linked across different data generation jobs where we've de-identified the data. Let's look at this example where we have a city column with 3 values of Boston. We want to consistently map these original Boston values to new mock values, ensuring that the output mock values can be linked to other data generation jobs where the same settings have been applied. If we preview the values, we see random values being generated, but if we enable consistent mapping and then preview the values again, Boston is now consistently replaced with this particular mock value. This consistency works across different data generation jobs and tables, maintaining data integrity and consistency across those tables and systems. If you have any questions or anything you would like to share, feel free to reach out to us via our website or schedule a live demo with us. Thank you for watching.